When graphing rational functions, we consider the vertical and the horizontal asymptotes to help us graph the functions. The vertical asymptote is a vertical line approached by the function. Its equation will always be x equals a number, and it is found by factoring the function, reducing it, and then setting the denominator equal to 0. So let's find the vertical asymptote for this first example. The equation is completely factored and reduced, so we set the denominator equal to 0. So we set x plus 3 equal to 0, and we solve. So subtract 3 from both sides, and we get x equals -3. So that is the vertical asymptote for this function. And a function could have more than one vertical asymptote, but this particular function has only one. So now the horizontal asymptote. This is a horizontal line approached by the function. Its equation is always y equals a number, and it's found by determining what happens when x becomes very large. What this looks like in practice is we've reduced the largest power of x in the function, and we ignore the other parts of the function. If the greatest power appears in the denominator but not in the numerator, the asymptote will be 0. So for this example, y equals 5x over x plus 3, the highest power of x is 1. We have 5x on the top and x on the bottom. So to find the vertical asymptote, we just consider those highest powers of x and we ignore everything else. So in this case, we ignore the plus 3 in the denominator. And then we reduce. So x over x cancels and we're just left with 5. So the horizontal asymptote is y equals 5. And that information would help us graph the function. Example 2, find the horizontal and vertical asymptotes and then graph the function. Y equals x plus 2 over x minus 4. To find the vertical asymptote, we set the denominator equal to 0. And then we solve to get x equals 4. Now, since we are going to graph this function, let's go ahead and graph that asymptote. Normally, we graph an asymptote as a dashed line to show that that's a line that the graph approaches, or a line approached by the graph. So that's the vertical asymptote, x equals 4. Now the horizontal asymptote, we look at the highest power of x and ignore everything else. So in this case, we ignore the plus 2 and the minus 4 since the highest power of x is x to the 1. So ignoring the 2 and the -4, we have x over x, which we reduce to get 1. So the horizontal asymptote is y equals 1. So now to graph the function. A rational function normally has two pieces, so it looks like this, or like this. So to figure out what the rest of this graph looks like, if we plug in a couple of points, we could determine what happens with the rest of the graph. So one point we could plug in is 0. So plug in x equals 0 to get a couple points on the graph. That would give us y equals 0 plus 2 over 0 minus 4, which is 2 over -4, which is -1/2. So the point 0, -1/2 lies on this graph. Okay, let's plug in a few more points, like the point x equals 5. Plugging in x equals 5, we would get 5 plus, or y equals 5 plus 2 over 5 minus 4, which is 7 over 1, which is 7. So the point 5, 7 is on this graph. And we could plot more points. So let's plug in one more point. Let's plug in x equals 3. That would give 3 plus 2 over 3 minus 4, which is 5 over negative 1, which is negative 5. So that gives us the point 3, negative 5. And from there we can see, knowing what a rational graph looks like as one of these two possibilities, that this graph will look something like this. And you could plot more points to get a more accurate graph, but you use the asymptotes as guides and then plot a few points to see where the graph appears. Example 3, find the vertical and horizontal asymptotes and then graph the function y equals 2 over x minus 1. So starting with the vertical asymptote, we set the denominator equal to 0, and then we solve. So add 1 to both sides to solve, and we get x equals 1 is the vertical asymptote. Which we'll draw as a dashed line at x equals 1. Now the horizontal asymptote, we think about what happens as x becomes very large, or we think about reducing the highest power of x. So here, since there are no x's in the numerator, only in the denominator, as x becomes really large, nothing happens to the numerator, but the denominator becomes really, really large. So we have 2 divided by a really large number. So what that approaches is the line y equals 0. So the horizontal asymptote is the line y equals 0. So whenever this happens where there are x's in the denominator but not the numerator, this will be the horizontal asymptote, y equals 0. Or when the highest power of x is greater in the denominator than it is in the numerator. So that means the x-axis is the horizontal asymptote. Now we plot a few points to see where this graph appears. So let's use the point x equals 0 and plug that into the function. Y equals 2 over 0 minus 1 is 2 over negative 1, or negative 2. So the point 0, negative 2 is on the graph. And then also we'll plug in x equals 2 to get y equals 2 over 2 minus 1, or 2 over 1, which is 2. So the point 2, 2 is on the graph. And now we can sketch the graph with its 2 pieces, each approaching the asymptotes. And you could get a more accurate graph, remember, by plotting more points, but this is the general shape of this graph. Example 4, find the vertical and horizontal asymptotes of y equals 2x squared plus 6x over x squared minus x minus 30. Let's start this time with the horizontal asymptote. So to find the horizontal asymptote, we find the largest power of x and ignore everything else, because we're thinking only about what happens as x becomes very large. So in the numerator, we can ignore the plus 6x because the highest power is x squared, so we keep the 2x squared. In the denominator, the highest power is also x squared. So we ignore the minus x and the minus 30, and then we reduce this. The x squared cancels out and we're left with 2. So the horizontal asymptote is y equals 2. So now to find the vertical asymptote, we want to factor everything that appears in this function. So the numerator will factor by taking out a GCF, or a greatest common factor. We can take out a 2 from those two terms and also an x. And we're left with x plus 3 after we divide 2x out of each of those terms in the numerator. The denominator we factor by finding the numbers that multiply to negative 30 that add to negative 1. That factor pair is negative 6 and positive 5. So now to find the vertical asymptotes, we want to first reduce this function if we can. None of these factors reduce. And then we set the denominator equal to 0. So x minus 6 times x plus 5, we set equal to 0. And to solve this, we set each factor equal to 0. So x minus 6 equal to 0, x plus 5 equal to 0. And then we solve. So the first one, add 6 to get x equals 6. And then the second one, subtract 5 to get x equals negative 5. So our horizontal asymptote is y equals 2, and we have two vertical asymptotes. X equals 6 and x equals negative 5.